So, hmm, hi everyone. We are discussing about this topic, important topic, which is in available in fifth unit, that is input-output system. Under input-output system, we are just discussing about the topic called as mass storage system. So far, we have seen what is a disk structure, what is disk attachment, disk scheduling, disk management, and we saw the overview of mass storage management, and that we saw about the structure, which has a spindle where the disk can be placed, and each disk will have a head, and it has sectors. Sectors is of size 512 bytes, and we have positions where it can be queued, and based on several disk scheduling algorithm, how the head can be moved to one position to another position. We have seen these things. So let me start with the next topic called as swap space management. Let me start with the definition. What is actually swap space? It is actually a virtual memory. It uses disk space as an extension of the main memory. So we already know we have main memory and secondary memory. So swap space is nothing but the extension of the main memory, which is actually a virtual memory, which is less common now due to memory capacity has been increases. We are not using the swap space now since we have the extension of the capacity of memory has been increased. Swap space can be carved out of the normal file system, or more commonly, it can be in a separate disk partition. Okay, swap space management, which have 4.3 BSD, that is allocates swap space when process starts, holds a text segment, that is the program, and a data segment as well. Kernel here, which uses swap maps to track the swap space use. Solaris 2 operating system allocates swap space when a dirty page is forced out of physical memory, not when the virtual memory page is first created. So file data return to swap space until write to file system requested. So without any request, it won't write the data. Other dirty pages go to swap space due to no other home, means they cannot go just like that. So it can't be in the physical memory. So the swap space is taking care of it. And next is text segment pages thrown out and reread from the file system as needed. There may be a question raised like, what if a system runs out of swap space? And if it is that the case, some systems may allow multiple swap spaces. And we will be seeing about the data structure for swapping on the OS, which we are taking here is called as Linux system. So we have swap partition or swap file is there, and swap mapping is there, and we have a separate area for called as swap area, and each block is called as the page slot. So let me repeat the advantage of swap space management. When there is it is actually an extension of a main memory, or we can say it as a virtual memory. The pages which are all which can't be present in the physical memory can be thrown out to virtual memory, where the swap space can handle the dirty pages. So whenever it requested, the swap space will return the data, write the data, otherwise it will be idle. So if we are running out of swap space, we can have the multiple swap space as well. So here is an example for the Linux system where we can have a swap partition or swap file is presented. Each block is called as the page slot, and we have swap map as well. This particular area is called as the swap area. Thank you.